Your IDE Autocomplete is great at what it does. You type a function name, it suggests the next parameter. You start an if statement, it fills in the body. It completes your thought, it doesn't do the work. But what if your coding assistant could take a task description, plan a solution, read your existing code, write new files, run the tests, see they failed, fix them on its own, and keep iterating until everything passes? All on your own hardware, without sending your code to any cloud API? That shift, from autocomplete to autonomous, is what agentic coding with local LLMs is all about. And it's already here. I use this stuff every day. So what do I actually mean by agentic coding? It's fundamentally different from what most of you are already using. Copilot suggests a token. ChatGPT generates a response. But an agentic coding system, an agent reads files, edits them, executes commands, and observes the outcomes. It makes decisions about what to do next, and it keeps going until the task is done. Think of it this way: chat coding gives you a recipe. It says, here's how you add authentication to your Fast API app. It might even show you the code. But you're the one who has to copy-paste, run the migration, fix the import, restart the server, and test the endpoint. Agentic coding cooks the meal. You say, add authentication, and the agent reads your app file, creates the auth module, updates the requirements, runs the tests, sees it broke something in the middleware, goes back and fixes it, and commits when everything's green. It has agency. It acts. It adapts. That's the paradigm shift. Under the hood, every agentic coding system runs the same core loop. I call it think, act, observe. First, think. The model receives your task and plans an approach. It might decide to read a few files first to understand the codebase structure. It considers what needs to change. Then, act. It makes tool calls, editing a file, running a search, executing a shell command. It's not just generating text anymore, it's modifying your actual file system. Then, observe. It reads the output. Did the edit succeed? Did the test pass? Is there an error message? Based on that observation, it loops back to think and decides what to do next. The architecture needs 5 things: a system prompt that defines the tools, context management to track what's been done, a parser to decode the model's structured output, an executor to actually run the tool calls, and error recovery, because models make mistakes and you need to handle parse failures gracefully. I run Hermes agent locally with Qwen 3 Coder every day, and this loop is the engine under the hood. It's what separates an agent from a chatbot. Let's talk about the tools. The ecosystem has matured fast, and there's a spectrum from cloud-only to local-first. At the cloud end, Claude Code is the gold standard. It's Anthropic's official agent, powered by Claude 4, and it's the best agentic coding experience right now, period. The model is smarter, faster, and more reliable. But it's locked to Anthropic's API. Your code goes to their servers. You pay per token. And you can't run it offline. OpenAI has Codex CLI, which is open source and sandboxed in Docker, but it's still designed for their cloud models. On the open source side, Aider is the most mature option. It's been around the longest, supports tons of models, has this clever repo map technique for context management, and it auto-commits to Git with sensible messages. It's what I recommend for most people getting started. Hermes Agent, which I built at Noose Research and use daily, is designed local first. It's built for open-weight models like Qwen 3 Coder. The whole architecture assumes you're running on your own hardware. OpenHands gives you a full web UI with Docker sandboxing and even a browser agent. SWE-bench from Princeton is the academic standard, it's what SWE-bench scores are measured with. And OpenCode is a lightweight, multi-backend option that supports Llama for local inference. The key takeaway: you've got choices. Everything from Claude Code if you want maximum capability and don't mind the cloud, to Aider or Hermes Agent if you want to keep everything local. Here's the question everyone asks: are local models actually good enough for agentic coding? A year ago, the answer was honestly no. Local models scored under 20% on SWE-bench, the standard benchmark for autonomous software engineering. They couldn't reliably call functions. They lost track of context. It was a research curiosity, not a daily driver. Today, the picture is completely different. Qwen 3 Coder 32B, which is what I run on my RTX 3090, scores 40 to 50% on SWE-bench. That's on par with where GPT-4 was not that long ago. It handles 128K context, follows complex agent prompts, and outputs reliable JSON for function calls. Compare that to Claude 4 at 60 to 70%. The gap is real, but it's closing fast, and local has the privacy and cost advantage. 5 things made this possible: better function calling training, longer context windows up to 128K, improved instruction tuning, the SWE-bench training loop feeding back into model improvements, and quantization, which lets you run a 32B model in just 18 gigs of VRAM at 4-bit precision. A 32 billion parameter model that fits on consumer hardware and can autonomously fix bugs and write features? That was unthinkable 2 years ago. It's my daily reality now. The magic that makes agentic coding work is function calling or tool use. Without it, the model can only generate text. With it, the model can act. Here's how it works. The model doesn't just output narration. It outputs structured JSON, a function call with a tool name and parameters. Something like call edit _ file with path equals src/appy, find this string, replace with that string. The agent runtime parses the JSON, validates it against the tool schema, executes the actual file modification, and returns the result, the new file contents, or any errors, back to the model as an observation. The tool set is pretty universal across projects: read _file, edit _file, create _file, bash, search _files, and git _commit. Some add diff preview, ask _user for clarification, or web search. Local models historically struggled with generating consistent JSON. They'd miss a comma, hallucinate a parameter name, or wrap the call in Markdown. But Qwen 3 Coder and other recent models are specifically trained on function calling data, and techniques like grammar sampling built into llama.cpp enforce valid output structures. The reliability now sits around 85 to 95%, which is good enough for practical use. So when should you use local, and when should you pay for cloud? Local wins on 4 big things. Privacy: your code never leaves your machine. I work on proprietary projects, and that alone makes local non-negotiable for me. Cost: you buy the GPU once, and every task after that is free. Offline capability: I code on planes and in coffee shops with no internet. And customization: you can use any model, tweak any prompt, add any tool. Cloud wins on capability, speed, context, and reliability. Claude 4 is smarter than any local model. It generates tokens at data center speed, you're not waiting 30 seconds for a planning step. It handles 200K context easily. And its function calling hits 99% reliability. The hybrid approach is what most serious users do. I use cloud models for hard architecture discussions and complex debugging tasks where I need the best reasoning. For routine work, boilerplate generation, simple feature implementation, bug fixes with clear reproduction steps, I use my local Qwen 3 Coder. It's faster in terms of my workflow because I'm not context switching to a browser or worrying about API costs. Hardware reality: 24 gigs of VRAM, like an RTX 3090 or 4090, is the sweet spot. Qwen 3 Coder 32B at Q4 quantization uses about 18 gigs. You can even run the 8B variant on any 12 gig card. Let me be honest about the limitations so you know what you're getting into. Local models still struggle with complex multi-file refactors, especially when changes have implicit dependencies across a large codebase. Speed is the biggest pain point. I'm getting 5 to 20 tokens per second, which means 30 to 60 second waits during planning steps. Function calling hits 85 to 95% reliability, and that 5 to 15% failure rate means agents sometimes get stuck on parse errors or hallucinate tool parameters. And if you're not careful, an agent can spin in a loop, making the same failing edit over and over. Setup complexity is real. Getting Llama or llama.cpp configured, downloading and quantizing models, pointing the agent at the right endpoint, it's not turnkey yet. But the trajectory is incredible. Near term, we're looking at Qwen 4 Coder, 1 million token context windows, speculative decoding for faster inference, and better tool use fine-tunes. Medium-term, on-device AI accelerators on Apple Silicon and Qualcomm chips will make this run on laptops. Long-term, local agents will surpass Claude for most coding tasks, and agentic coding will become the default IDE experience. We're not there yet. But we're closer than most people realize. Agentic coding with local LLMs isn't a futuristic concept, it's a tool I use right now, on my desk, on my hardware. The code never leaves my machine. The capability gap to Claude is closing every quarter. And the open source ecosystem aider, Hermes Agent, OpenHands, is building the infrastructure for how we'll all write software in a few years. From autocomplete to autonomous. From suggesting tokens to shipping features. That's the shift, and it's happening whether you're watching or not. Try Aider with Qwen 3 Coder 32B today. It's free, it runs on your hardware, and your code never leaves your machine. Drop a comment, what's the first task you'd let an autonomous coding agent handle for you? Subscribe for more on local AI development.